We are today at Emerging Technologies in Medicine 2020, and my name is Obioma Pelka from the University Hospital Essen. And I gave a talk on Yes We Can, but sometimes we don't scan. And it was giving a brief introduction of what GANs are, what are their characteristics, and how they could be used for medical image analysis. GANs are short for Generative Adversarial Network, with emphasis on adversarial. So we have, with emphasis on adversarial, so we have two models, the generator model and the discriminator model, who keep on trying to oppose and disagree with each other. So we have, for example, the generator model tries to copy and mimic the Mona Lisa, and the discriminator model keeps on trying to detect whether this generated image is fake or original, and it keeps on going on a loop with several iterations until some point the generator is able to trick the discriminator to think that this generated image is real. One advantage of GANs are that it is an unsupervised learning method. That means that we don't have to label data. We don't have to tell the architecture, this image is this. We just give in all the images and let it do the work on its own. Another advantage is when we have a data set without not so many images, just like small image number, and we have an interesting question, but we don't have enough images to tackle this question. We can use GANs to generate several variations of these images to have them more a bigger data set. And also GANs are able to capture some kind of data distribution which is beyond human comprehension. GANs are generally difficult to train. There is this problem called the mode collapse, where where the generator keeps on generating the same samples and doesn't learn again, and then the loop just keeps on going, and there is no end. Another problem is the vanishing gradients, where the generator is very quick and very good, and is able to trick the discriminator real quick, and ends up not learning again. And the idea behind GANs is to make the generator, to improve the generator, but also the discriminator. When the generator just says, "So I'm done, my job is done. I don't have to keep on learning because I'm able to trick the discriminator." That's not really. And another disadvantage or something to think about is the evaluation metric, because the discriminator checks the image and says yes, no. And so he says this yes, no, depending on the quality of the image and how good this image is. But then who defines what good is? Where do we say it's good enough or it's not good enough? And I think it's still a very challenging topic that we try and define the proper evaluation metrics.